Hi friends, I'm Muhammad Unais. Today I'm going to show you some network configure designs, especially which can be used for small office or home network, small or business networks. That's all. Here we have three designs. In first one, okay, in each of this design we have three clients, one server and one ISP model. In this in first one we have two networks, that is here ISP modem and Windows server is connected to a single network and these three clients as well as this Windows server is connected to another network, that is Windows server is the part of two networks. That means Windows Server should have at least two NICs, network interface card. That is, here suppose we have to connect it as, suppose our ISP model support USB. So USB cable can be connected to Windows Server, and server there will be network cables that can be used to connect to switch. Okay. Here we have three clients. So these clients will be used as this Windows server as its default gateway. That is, they are using its 10.0.0.11. That will be the IP address of Windows server. Okay. So in this in second one, everything will be connected to a single network, that is single switch, that is all the ISP and Windows server client 1, client 2 and client 3, everyone is in a single network. That's all. That is look at their IPs 192.168.1.1, 192.168.1.11. It is 101, 102 and 103. That is everything is connected to same network, and all of them will be our same subnet mask. Okay, but here these three PCs clients use as this server as default gateway, that is 192.168.1.11. So it is client 3, client 2, these three clients uses Windows server as default gateway, and this Windows server uses this ISP modem as default gateway, that is 192.168.1.1, 192.168.1.1 its IP. That's all. In third network design, as shown in second, we have three clients and everything, and server, ISP modem, and all of them are connected to single network. But the difference is that all these four, that is clients, the three clients and server is directly uses this ISP modem as their default gateway. Okay. Okay. Suppose when this client want to communicate with a web server, suppose a client want to use a Facebook, so this client will be send a request to Windows server, then Windows server will send the request to ISP modem, and then to public network, and the reply will be comes as vice versa. In this network, in this network, in Windows server maybe want to block some other PCs using internet, that is the client server, if we are using domain name Active Directory, the Windows server can be used. The client one does not allow to enter Windows server, or it will be it can be a block. It can be makes a special permission, such as the client 1 and client 2 is only allowed to use the internet, or some of the users are allowed to internet and another users are not allowed to enter internet. Everything can be done. That can be by controlling default gateway, because it is uses its default gateway. But in this network, the same way they are using, these three clients are using this server as default gateway. But the problem is that if the client has a permission, that is user have a permission to change the default gateway to this ISP modem, he can be directly connected to this internet. But it is not possible into this in case, that is, if you are blocked, client to do doesn't use internet. Okay, if even the client to the user in the client has a permission change IP address, it cannot be used. That's all. In this network, in third network, everything will be directly uses default gateway as Windows Server. Okay, now let me look how this routing will be takes place. Okay, first of all, the client 1 want to communicate with the client 3. So client 1 will be known about the IP address of client 3. Now the client wants to know whether this client 3 belongs to same network or not. Okay, for this purpose, this client 1 will be used as subnet mask. Okay, okay, IP address of client client 1 will be 10.0.1.101. Okay, I'm converting it into binary. Its corresponding binary is 0001010.0810. That's all. This is the binary of the IP 10.0.1.101. That's all. That is every 8 octals is every decimal. Here every decimal is an octal. That's all. Now it will be its subnet mask. It will be 255.0.0.0. Okay, now this is the IP address of client 1 and subnet mask of client 1. Now client 1 will be multiply it with the IP address, multiply its IP with its subnet mask. So it will be get its network ID. That is, its network ID will be 000.1010.0. That's all. That is network ID. Client 1. What is this? 10.0.0.0. Okay. Next, the client 1 now the client 1 communicate with the client 3. So client 1, first of all, client want to find out whether this client 3 belongs to the same network or different network. So for this purpose, in client 1 IP address of client 3, this entire items are takes place now on client 1. So IP address of client 3, that is 10.0.0.1.103. okay, and subnet mask of client 1, it will be similarly 255.0.0.0. So it will be again multiply with this IP. It will be network ID of client 3 with respect to client 1. Okay, so it will be 10.0.0.0. okay, that is client 1 will be now IP address of client 1, its subnet mask, and also IP address of client 3. First of all, it multiply IP address of client 1 and subnet mask of client 1. Now it will be collect network ID of client 1 with respect to client 1, that is 10.0.0.0. Now it will multiplied IP address of client 3 with the subnet mask of client 1. Now it will be get network ID of client 3 with respect to client 1. It is same, that is in both the cases we have get the same network ID. That means this client and the destination is in the same network, so it can directly send this packet. Got it? Okay. Let's suppose this our destination is not client 3. Suppose we want to communicate with Facebook. Okay. So first of all, we want to know Facebook IP. Okay. In the same way, what we do, that is okay. Now client 1 will be now IP address of its and subnet mask. It will be multiplied client this IP and subnet mask. Now it will be now its network ID. Now it will be use IP address of Facebook. IP of Facebook. Now we will be take its subnet mask. That is subnet mask of client 1. It's nothing but 255.0.0. Now it will be multiply and it will be get what network ID of a Facebook with respect to client 1. So when we multiply it with, it will be get 255 and 69 is nothing but 69, and the remaining will be 0. That is now we got here we got 10.0.0, and here we got 69.0.0.0. That means that is first client 1 multiplies IP address its own IP with subnet mask, then it will be its network ID. It is found to be this one, and it will be make IP address of Facebook with the subnet mask of client 1. Now it will be get network ID of Facebook with respect to client 1. Here both of them are different. That is now this client 1 can assume that the Facebook is in the same is another network, so it will be send the request to its default gateway. So for this purpose we are using default gateway. Now this client 1 will be sends its request to default gateway. So default gateway is nothing but it will be reaches at Windows Server. Its default gateway is 10.0.0.11. Now this request will be reaches at this server. Okay. In the server we have two NICs, so there will be okay. So when this request to Facebook, it will be arrives at the server. In the same similar way, server will be tries to find out its network ID as well as the network ID of the Facebook with respect to the server. But here we have two network interfaces. So first of all, what we do, the Facebook Windows Server will first multiply this IP with this subnet mask. So it will be get network IP address of this one. It is nothing but 10.0.00. Okay. Also it will be multiply this IP 192.168.1.1 with 255.255.255.0. Now it will be gets its network ID, that is nothing but 192.168.1.0. Okay. Now it will be now it's both the network IDs to which the server is connected. This network ID is 192.168.1.0 and this network ID is 10.0.0.0. Now it will be multiply the IP address of the Facebook with the same subnet mask. Okay, so what we do, it will be multiply with it with the subnet mask. The same processor will be takes place as server. So it will be get a subnet network ID of 69.0.0.0. Now it will be not in this network. That's all. So it will be try another interface. That is, in another interface, its IP is 190. The IP of Facebook is 69.172.201.208. And the subnet mask in this network is 255.0.255.0. So it will be this network ID or the network ID of Facebook with respect to interface of the first interface of server. It will be 69.172.201 and 0. Okay, here we got two different network IDs. Got it. Server in this network ID 192.168.1.0, here 10.0.0.0. So these two networks IDs are entirely different. That is, it doesn't belongs to either this network or not in this network. In such a situation, the server will be sent forward this packet in its own default gateway. That is, its default gateway is 192.168.1.1. So it will be forwarded into this network ISP modem. So this packet will be reaches at ISP modem. ISP modem will be house two interface as we are discussed in the same way of server, because it will be connected to this network as well as it will be connected to ISP provider network. That's all. So it will be continuously routed to until it reaches Facebook, and the reply will be arrives. Okay, that's the use of default gateway. Next we study about DNS, domain name server. That means if we want to communicate with Facebook but we doesn't know about what is the IP of Facebook. Okay, for this purpose we are using domain name servers. Our domain name server will be contain some databases in a simple words. It will be the DNS will be consist of some databases. There will be the IP and the corresponding name will be saved in that database. Okay, so here we can use either also it's a Windows server, so we can implement a DNS server on this PC, or we can use as DNS as ISP modem or the ISP provider DNS server, or the DNS servers or Google or anything can be used if they are if you have permission to access them. That's all. So the client, suppose the client 2 uses DNS as Windows server, and so that is we are implemented DNS in Windows server. Okay, and it will be tries to find out IP address of Facebook. So it will be whenever it tries to access Facebook, first it will be send a DNS request to corresponding DNS server. That is, I have a name that is www.facebook.com. I want to find out its IP. So Windows server will be searched in its database. Oh, this is the IP. Then it will be find out the IP. Oh, this is the IP of the Facebook, and it will be replaced to client 2. Now the client 2 will be not IP. Now it will be send the package to Facebook. That will be carried out through this Windows server and ISP modem, and so on. That's all. Suppose the client 3 uses DNS as ISP modem. That is, it will be uses 192.168.1.1 as ISP modem. Okay, so it will be sent. First, it will be send a package to 192.168.1.1. That is, I want the IP address of a domain. But whenever this packet will be reaches at Windows server, it will be routed this packet into ISP modem. That is, whenever we are trying to resolve a domain, that is, resolve means we want to find out IP address of a domain name. It may be routed. it will be takes place routing, that is it will be directly routed to Windows Server. Then Windows Server will be directly send it into ISP modem. ISP modem will be find out to the IP of Facebook. Suppose if it is not in that ISP modem, it will be sent to the higher level DNS server, that may be in DNS, the ISP provider DNS server. Okay, so that's the use of the DNS server. If we can also implement it in the Windows Server, so that we can control, we can block some IPs, or we have to forward some port numbers to some other IPs, or suppose when we type facebook.com, we have to send it into Google. Everything can be done using this DNS. That's all the use of DNS server. Next we are study about DHCP server. Okay, actually what is the use of DHCP? That means, suppose I am connecting a new PC, suppose client 4, I am connecting it to the same switch. Okay, how it will be gets an IP? That's the use of DHCP server. That is, the DHCP server will be provide an IP address to this client. That is, for this purpose, we must be implement a DHCP server. In this network, we must be implement DHCP server in this Windows Server. Got it? Otherwise, we get an IP. If you are not implemented DHCP server in the Windows Server, we have to manually type these IPs as, suppose I am connecting client for its IP is 10.1, 0.0.104. I want to manually type it. Suppose whenever I are connecting a network, when connecting a PC into a switch, it will get automatically an IP. This is provided by Windows DHCP server. In this method, we must place a DHCP server in this network. Okay. Also, suppose in this network, but in this network we can default to use DHCP server which is provided ISP modem. That is, ISP modem will be provided DHCP server. Okay, we can use its default. That is, when we are connected to this client for, when we connect client 4 to this switch, it will be this. There will be a DHCP server running on ISP modem. ISP modem will be producing IP for this client 4. Okay. The similar way it will be takes place in this client 4, in this design. Okay, then DHCP DNS. Okay, so if you try to implement this network, we don't use default gateway here. It will be leave as empty. Got it? Okay, that is, client 1, client 2, client 3 and Windows Server are in this network, and they are using an IP 10.0.1.1 and something else, and these three uses default gateway as server. Okay, this Windows Server uses default gateway as ISP modem. So this configuration, we must have at least 2 NICs in Windows Server. So first NIC can be connected to this and another NIC can be connected to this. That's all. Here it is not required. Here it is only single NICs and big enough. But the problem is that here this client 1, client 2, client 3 are uses default gateway as this network Windows Server, and Windows Server uses ISP modem. But the problem is that if a client 2 has a permission to client 2, that is user on the client 2 has permission to change its default gateway, it can directly connect into the internet. Okay, in this configuration everything is directly connected. Suppose if you want to implement this web secure network, we have to use, I think we have to use this one. This is the better because everything is passes to this server. So even if if you are blocked with someone, he cannot be use it. That's all. Okay, that's all. So okay, thanks everybody.